I think it's live. Cool.
We're getting ready here. Could you just give a medium rule on advice on the camp? So really can we be with the constructs and the SEM, or should we stick closer to the assigned concepts?
Say again? Are you wondering how closely you can, how far you can do?
I would like ideas of DB.
Can you change it?
To my mind, I've looked at it a little bit. You know, optimism, IT, group, and we make a technical contract called emotional kind of stability, maybe moderated by LMX to work dedication. But that's, I'm thinking too much of a play.
So here's the overall rule, or thought perspective, I don't know what you want to call it. You need to test mediation, multi-group moderation, and interactions. You need to have some controls in there, and you need to hypothesize about all that and report it nicely. If you can stick to the model, that's fabulous. If you think there's a better way, I don't think anyone will wrong you for thinking. Yeah.
And the biggest kind of notion there was to take the trouble DB.
Yeah, move it. Yeah. I think that's a clever idea. Yeah.
Although I've been flunked on clever before.
Yeah. That's what you get for being clever. All right. Let's see. All right, we're going to get started. Looks like most everybody's here. This is great. I hope people from out of state had fun last night. Did it hail on you? We got a bunch of thunder and lightning up in Linden. Huh? And we have a bunch of hail, too. Hopefully the clouds will clear and we'll be able to see all the snow in the mountains. I need to share my screen. Let's see. All right, welcome, Hangouts remote folks. I'm going to share my screen with you. Today, we are doing CFA, and I have a heap of slides on this, but I'm not actually going to present many of them, I don't think. It would be like yesterday where I'll go through, I think my mic's muted. Wait up. Nope, we're good. Okay. We're going to go through the procedures more, and then we'll review the slides if necessary. This is a sort of an FYI slide, so I won't go over that. For anyone who might not be familiar, you go from an EFA directly to a CFA. So you take the pattern matrix, and out of this you build in Amos a fairly complex measurement model, which was exceptionally painful and error-prone until we created a plugin to do it. So let's go do that. For those who doesn't have the plugin, who would like the plugin? Okay, so let's just go through how to do that. Okay, so, ooh, that's pretty. Let's go File, New. So open up Amos. Actually, don't open up Amos if you're getting the plugin. I'll close this. What you need to do is go to the stat wiki, and on the left you'll see Amos EFA to CFA plugin. I have another plugin. It's a common latent factor for common method bias plugin. So every now and then I get a real clever student as a research assistant who wants to program something for me. So every time I do, I just have them make a new plugin for Amos. So we have a couple here. I have another one that doesn't work, so I hope you don't have that one. Use this, and what you do is right-click it and save link as. Do I need to wait? I guess some of you are still getting set up. I'll wait for a sec. But I strongly recommend using this plugin over doing it manually. You will literally save 30 minutes and won't have errors. Yes?
The plugin doesn't work on Amos version 19, right?
It might work on 19.
But I kept getting an error.
Oh, you're on a Mac. I know there's a Windows side. Yeah, is it Windows 8?
Windows 7.
Oh, good. there could be other issues. Yeah, Amos and Mac, even on the Windows side, is real finicky. Yeah. There are also licensing issues with SPSS and Amos that they don't like plugins sometimes. So if this works, it's fabulous. If it doesn't work, I greatly apologize and mourn your pain. All right, are we ready? So what you do, you go to StatWiki, and on the main page, on the left side, there's this resources area. It's the Amos EFA to CFA plugin. You're going to not left-click it. If you left-click it, oh, that did work. How about that? Discard. If you want to right-click it and save link as, and save it just to your desktop. Here's what you'll see why. I never save things to my desktop, but this time save it to your desktop. So save. Don't click to open it. You're just going to minimize things. You'll see it on your desktop. And I have a video that goes through how to do this. If you miss all this, there's a video, and I'm recording right now, so you have 2 videos. You got to right-click it and go to its properties. Slow me down if I'm going too fast. I don't want to lose anyone. Okay, go to its properties, and now at the bottom on the general page, it's going to say there's a security issue. You just downloaded a driver. This can affect your computer in many serious ways. And this one won't, but there's that chance. So you have to unblock it. If it says if there's a button to unblock, click unblock. Not all of you will have that button. You right-click that file that you had, go to its properties, unblock it, and hit OK. On the General tab, there might be an unblock button on the bottom right. If there's not, you're good. Hit OK. And then only once it's unblocked do you want to go stick it in your Amos folder. For me, the easiest way to find my Amos folder is to type 21 into the search area, because that's the version number I have. And I don't have many other 21s. And I right-click the license authorization to go to the file location. Or you can find it another way. It's in IBM, SPSS, Amos, 21, English, or something like that. I'll find the path. Oop, not run as administrator. Ah! Oops. Cancel. Cancel. Yes, I want to cancel. Oh, I hope that doesn't mess things up for today. Open file location. And here I am. So here's the path. It's in your program files, x86 if you're running 64-bit machine, IBM, SPSS, Amos, 21 plugins. That's the folder we want to go to. And then you just drag it into there. I already have one, so I'm not going to drag it in. And so it should show up here as patternmatrixbuilder.dll. Anyone need assistance with that?
So the Amos 21.
Yeah. Let me increase the size of this. Let's see. Here, 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 here. That's the path. Good. Need help? Yeah, Windows side on Mac. It's great. It's good. There you go.
So you get to go to properties. No, I'm not working. Okay. There is no one else.
Yeah, so my professor has Amos download on his computer, which she runs and then she no, like, I saw it.
You find it easy to avoid like a personal.
I was thinking about getting that, but I was like, no, my software is all that stuff.
So I'm back.
Everyone in my office was that. But my was trouble with doing the pizza, and she's just like, I can't do it. And then we were we'll just ask for it. There's not a class.
Once you get that far, close Amos and reopen it and check your plugins menu. You should see that it's there. Hopefully it worked. I don't think that's ever going to you did something. But it doesn't want to.
Use the Amos plugin. You have to do the CFA real fast. It's really neat.
There we go. Okay.
That's what we're doing. These are your genius.
And then
I thought you were going to today. Like, I thought you knew we were doing fun too. The crazy thing is like how like the fingerprints, you know? Like I never had one. My expired 23.
okay.
So we were 23. I was telling you stuff. It's just everything's so much. Oh,
You think this plugin is going to work with 32 of us?
yeah, it does. Yeah, it does. I think.
Okay.
Did you
Okay.
do you have plugins?
Yeah.
We'll do your plugins page should be in there.
Okay, so it should show up in your plugins menu. Sorry, remote folks, I'm back. Let's move forward. So the whole reason we did that was actually to save time, believe it or not. Let's see, back to here. So if I go open Amos and I link the data set we were using, data files. Who here has never used Amos? Okay, this is good. And is following along. Okay. Amos is one of the more user-friendly statistical modeling packages. And it's all relative. That's like saying you just found a cute cockroach. It's all relative. Yeah, I hope that's not discrimination against cockroaches. I don't need a legal battle right now. So to link a data set, you don't go file open, you go file data files. And then double-click the group number and go find that data. For me, it's in recent places, data, boot camp trimmed _1. That's the data I'm using. I'm going to hit open. And if it worked, it should show up here as file name with the sample size. N represents sample size. So yesterday we were in pretty familiar territory for most people. Today, I guess we're getting a little bit less familiar territory. So that's fine. We have a whole day just for CFA. So get that data linked up. Again, if I go too fast, stop me, raise your hand, don't be shy. We have time to answer questions. For those of you who got this, again, feel free to go about your business. I'm going to hit OK. Okay. Now, nothing happens. Yay! Which means something happened. The data set is linked, and now what we want to do is open up that output file from yesterday. I saved it in the data folder, and this is the pattern matrix we want. Or if you have your own pattern matrix, link your own data set and get that pattern matrix if you have the pattern matrix model builder. Yes?
Do all of our items need to be in the pattern matrix for the CFA?
All the ones you want in the CFA?
So we're making, let's say for instance I'm making a structural model,
Mm-hmm.
and I have 5 different variables that I want to put in my structural model. Do they all need to be in my CFA? CFA?
The only variables that should be in your CFA are reflective latent factors. The items that belong to reflective latent factors. If you have other things like age and education or other observed single item variables, those don't belong in a CFA.
Okay, but I would need to have all of my variables assuming they're reflected in my...
Ideally, yes, in your pattern matrix. Now, if you're working with a second order factor, that might not work. You might have to do this by hand. So let me show you how to do this by hand first. And I'm not going to do the whole thing. I'm just going to do a little bit of it because it's painful and time-consuming to do the whole thing. So we wanted to create latent factors out of useful, enjoy, decision quality. So what I would do is I'd click on this little menorah candelabra thing, and then I'd set the size by clicking and dragging, set the size of my initial latent factor, and then I click on this again and again and again and again until I have how many? 7, 1, 2, 3, 4, 7 for usefulness, 5, 6, 7, and then I don't have to click and drag on for the next one. I can just click and it's the same size now. And how many do I want for enjoy is also 7. I'll do one more. Decision quality 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I would rotate these. Preference is having the latent factor on the right now. In older versions it was on the left. Don't know why they moved it. I use this little tool to rotate them for those who are following along manually. And then use the fire truck. Again, this makes perfect sense. And the balloons to move the latent factors all together. If you don't use the balloons, you're in trouble. Yeah, Control Z. Okay, so use those balloons and the fire truck. It might be a moving truck, but it looks like a fire truck to me. Anyway, so now we have them all pretty and lined up. But really, you do the whole pattern matrix. And then you'd want to covary these 3. Now, you can either do it manually with this little double-headed arrow, or if you want, you can do it, like if you have a lot of these, you can highlight all these latent factors and use a plugin called Draw Covariances. Oh, nice. Now it's on the left. Okay, I'll rotate. Rotate, rotate, rotate. I can never remember which versions have it on the left and which have it on the right. So you should end up with something like this, an empty husk. Yeah, the covariances. You would highlight with this little finger pointer, the booger picker, highlight each latent factor, and then go to Plugins and Draw Covariances. Okay, and then the closed hand that makes you want to punch something is the thing that deselects everything. Open hand selects everything. Deselect with a punch. And now we have a husk, an empty husk, that you then have to manually fill out. There's a way to do this. If you click on this little white stacky thing, it'll show you all the variables in your model, or in your data set that's linked. If you don't have anything in this white stacky thing, it's because you haven't linked your data set yet. And so you would drag over, so we had usefulness first, I think. You would drag over useful 1 to this box. Oh, useful 2 to this box. Useful 3. You see how this is pretty painful. I mean, it's arduous. Yeah. So let me show you how to fix that. You go to View, Interface Properties, and you go to Miscellaneous. And instead of displaying variable labels, you uncheck that and hit Apply. That was View, Interface Properties, Miscellaneous. Display variable labels is unchecked. Apply, and then we see now just the variable names. This is very painful. This is why I made the plugin, or had the plugin made. This is awful. So let me show you the easy way. There's also no easy way to like select all and delete it all. I have to.
First time you do this is miraculous.
Yeah, if you're used to doing it, some other way. But if you're used to this being the way, boy.
Plugin becomes the luxury.
Yes, and now we're spoiled. So there's no easy way to delete everything. You have to do it one by one. Yeah. Or you can just create a new canvas, which is probably faster. But then you have to relink the data. There we go. Don't miss anything. Isn't this such an intuitive interface? And user-friendly, might I add. Okay. So the quick way is, yeah, the quick way is, if in your pattern matrix they are displaying the variable names, not labels, and if you're using the US decimal instead of comma, I think I might have, no, I didn't fix it. It's just if you're using decimals. If you're not using decimals, this is going to throw up on you. You would copy this, because a lot of European folks in other countries use commas instead of decimals, which seems way backwards to me. Anyway, once you've linked your data, and you go to your pattern matrix model builder plugin, all you have to do is paste, Control V for me, Command V for some of you, paste that pattern matrix and create the diagram, and hope it works. If it doesn't work, I apologize.
Quick question,
Yes.
so on the SPSS side, if my pattern matrix has the labels instead of the...
Then what you want to do, okay, so the question was if in SPSS, if the pattern matrix has labels instead of names, what you want to do is go to Edit, Options, and in the Output tab, click on Names instead of labels at the top, and also in the pivot table, Names instead of labels, and then hit OK. And then you have to rerun that pattern matrix. Okay. Have I thoroughly lost a few of you? Yeah, there's a huge list. The pattern matrix I used was, let's see, the very last one before reliability tests. There are 3 reliability tests in a row, and it's the very last one before that. Okay. Any other hiccups before we move on? Because it's going to be really hard to follow along if you don't have a CFA to work with. Okay, I'll give a couple minutes. Remote folks, I better see if you guys are dying. Could you repeat, please? Uh-oh, which part? How to add the plugin. Okay, how to add the plugin, again, go to StatWiki, and it's on the left here. The Amos EFA to CFA plugin, you're going to want to right-click it and save link as, or whatever your browser says. It's the save file thingy. And save it to your desktop. Let me know when you get to that point. Okay. In fact, you can share your screen with me if you want, and then I can just see where you're at. Do you want to do that? Cool. Oh, on the left, see the green monitor with an arrow in it? Click that. And then click screen 1 if you have multiple screens. Cool. Ha, I can see your screen. All right. So go to your desktop. Can you get to your desktop? Cool. It's just not updating, I guess. Present to everyone. Yes, there we go. Okay. On your desktop, right-click the plugin. I can't see. Your screen's not updating, apparently. It's just staying on Amos. Oh, well. Oop, and then it disappeared. Oh, well. Right-click that plugin. And go to the properties. I'm not sure how you're doing, but go to the properties and see in the general tab if, oh, your screen's back. Cool. And see if there's an unblock button on your general tab. And if there is, go ahead and unblock it. Good. And then you're going to go to the folder. This, oh, did I close that? Tell me I didn't close it. Let's see. Boom, boom, boom. I did. I closed it. Awesome. This folder, oh, you can't see my screen. That's right. Let me share my screen with you again. Okay, stop. And I'm going to share my screen. Share. There we go. Me. Okay. Now you should see my screen. You want to go to this folder, that program files x86 in your C drive. IBM SPSS Amos 21 plugins. And you drag that file into that folder. If all else fails, I have a video on this that'll show you how to do it if you need a review. Okay, anyone locally need catch up? Need to catch up? You have to restart Amos. Yeah. Good. Yeah. Okay.
These files say, and it keeps saying it's .spv. Yeah, but then when I go into Amos to try to use that data, it's not SPV. Well, I keep trying to resave it as SPV. So it's because you're saving the output file. You want to save it. Okay. Yeah, so go into SPV. So this, if you save it, you save it as SPV. Using an output file, that's SPV. And that's what I just do.
Okay, I'm going to show one more time how to use that plugin once it's in place. So, and then we'll be up to speed hopefully, and we'll move forward. Today is truly a workshop. Let's see. So assuming you have the plugin in place, let me close Amos just completely. No, I don't want to save. So I'm going to open Amos. Hide that. Going to link my data set. File, data files. Go find whatever data set I'm going to use. For me, it's this one. Open. And now the data set's linked. I have the plugin. So I'm going to go to the Pattern Matrix Model Builder plugin. Open that up. It won't let you open the plugin area? Yeah.
Click on where you're trying to get your data.
Oh, file, data files?
Yeah. Right there.
Yep.
Click on.
So you want to link the .sav file, not the .spv file.
Yeah, that's what I'm trying to do.
All right. Just a sec, guys.
Well, that's what I'm.
I'm having trouble getting my things to build.
That's one of those things. No. No. All right. So you got to find that data. So there's not that an example file. This is that's the data set. That's the output. Remember that one? Yeah. Okay. So that's file data. One more time to show us which factor analysis you used.
Oh yeah, the pattern matrix I'm using is in the output, it's the very last factor analysis before I start doing reliability tests. Yeah, there are 3 reliability tests. The one right before that is the pattern matrix I'm going to use. So I'm going to right-click it and hit copy just on the pattern matrix. And in Amos, I'd go to Plugins, Pattern Matrix Model Builder, and just paste that pattern matrix. Again, if you're using commas instead of decimals, it'll probably yell at you. If you're using labels instead of names for variables, it'll yell at you. And if it doesn't like you, it might yell at you. So it's not entirely reliable on Windows 8, I know that, or in version 18 and lower. So you end up with this, hopefully. If not, you have to manually build that. The first thing you'll want to do is rename all of these, because these names are useless. And I'm sorry this is so small. Let me zoom in. The way to zoom in is just to scroll while on the canvas. That zooms. So I'm going to double-click the latent factor. Double-click that circle. Just rename this as useful, because that's what we are here. And you can just single-click on the next ones. This one's enjoy. This one is decision quality. No spaces in your variable names. This one is A-tip use. Scroll down. This one is playful. Pump use. This one's info act. There's one other thing you need to do. I'll let you get to that point. Just rename those variables. The next thing, yes? Yes, that's what we're going to take care of next. So what are all these ones? What? Oh, just intuitively what the variables are named here. Yeah. What are all the ones here? These are indicator regression weight constraints. Amos assumes that you have one constraint per latent factor. And so automatically it places it on this on the first regression line. What we're going to do is we're actually going to move it. We're going to move it off of the line, go to the parameters tab. If this closed, just double click that line. And you'll see the regression weight is constrained to 1. That's going to force the unstandardized regression weight to be 1, which we don't want. We're going to just delete that. We're going to do that for each one of these. Just going to delete it. It forces the natural slope, the unstandardized regression weight, to be 1, exactly 1. Isn't that weird? Yeah. So I don't know why it does that. It's just one of the assumptions of Amos.
That blows my mind. I went to last year's class that you always have something on 1.
You do, and so now we're going to place the 1 in the variance of the latent factor.
Oh, I see.
This frees things up a bit. So you double click on the latent factor, go to the parameters tab, and in the variance box you type 1. It should end up looking something like this. Yeah?
That's very common to assign a value of 1.
For a good reason, yes.
For a good reason. Interpretability of the other associated factors or items. But why was
zombie and I don't know how to do it.
Yeah. So the question is there an advantage to assigning the constraint of 1 to the latent factor variance instead of the indicator regression weight? There are 2 advantages I see. The first is that allows equal and liberated covariance between the indicators, which is what we're looking for when doing a factor analysis. There's no weighting or constraining there. And also, then the variance constraint is applicable to all of those indicators equally when it's on the latent factor. Also, later on down the line, when you're doing some analyses like common method bias and invariance tests, things just work out more smoothly when the variance constraint is on the latent factor. Did you have a question?
Yeah, I don't really understand what
so what it is it's forcing, in the case of a latent factor, it's forcing the variance to equal 1, the statistical measure of variance to equal 1, whereas when it's on the regression line, it forces the slope of the relationship for that line to equal 1. And so what we're trying to do is allow fair treatment to all these lines. Yeah. Okay. It's because Amos won't run. Amos won't run unless something is constrained to 1 on each latent factor. It will yell at you. So watch. If I get rid of this one, and let me save this before I move on. Recent places, data, go to Amos folder. So I'm going to save everything in my Amos folder here. CFA initial. All right, I'm going to run this by hitting the abacus, of course, and it will not run. Did it run? It shouldn't run. There we go. It says the model is unidentified. You need 1 additional constraint. So it doesn't run. You see, I get no estimates, and this one's unidentified, where I remove that constraint. So in order for it to run, I have to have at least one thing constrained to 1. Okay. Hopefully we're somewhere around this spot. If not, this is recording, and you'll be able to catch up on your own. The next thing we want to do is set some preferences. The colored abacus is where we have the properties for the analysis. So we're going to click on the colored abacus and go to the Output tab. And we want the standardized estimates. And for now, we can also throw in the modification indices. Why? Standardized estimates are the standardized regression weights, and also gives you a correlation matrix, which is nice. Whereas if you don't check that, you don't get those things, and we need those things. Modification indices are for later. They're for assessing model fit, which we'll do in a bit.
Let's go back to yesterday. You mentioned it depends on what your application is, whether you standardize.
Yeah, your field. Yeah, in the CFA, no. In causal models, yes. The question was, does this depend on which discipline you're in? No, for CFA we always go unstandardized. Standardized. Yeah. Okay. Again, to get to that, you click on the colored abacus. Okay. I'm going to save it and run it just to show you what things are, to help make some sense out of this and explain maybe why we're doing what we're doing. So after you run it using the regular black and white abacus, nothing happens, so something obviously happened. You click the up arrow, again obviously, and then things show up, but the wrong things show up after you click the up arrow. You actually need to click on this little itty bitty standardized estimates toggle switch. Then we have what we want. Again, very intuitive. Okay, and I'm going to try to explain some of this. Do I need to slow down, or are we all roughly in the same spot? To get to the estimates showing? Okay, so redo to this. So the little colored abacus is where we'd start. And you go to the Output tab, and then check the minimization history, standardized estimates, and modification indices. These are not the ones you check every time. These are just the ones we sort of need right now. There are lots of things we can do here. If you are missing values in your data set and the variables you're using, you'll have to also go to the Estimation tab and check estimate means and intercepts. But we don't have missing data in these variables, so we're not going to do that. Also, if you do that, you can't run modification indices, so you have to uncheck that. Very convoluted. Okay. Then you'd close this. There's no OK or apply button. You just have to close it. And then save it, because it won't run unless you save it. So don't forget to save. Yeah. So you don't have rights to write to that folder. You have to find a folder you have rights to write to. Oh, can you create a folder there? Yeah. Once you get to that point, click on the black abacus. And it thinks about it, does nothing. Click the up arrow and standardized estimates. Oops. Are you using a trial version? Sorry about that. I'm going to have to move forward, but this will all be recorded for you. Okay, we're going to move forward. Hopefully I haven't lost all of you who are following along. Let me explain some of this stuff. So these are the latent factors. These are the factors we observed in the pattern matrix. So, for example, useful here is represented as factor 1. Useful here, the first factor, is comprised of these items, which are these items, funny enough, in the same order. And these indicator loadings, if you're looking at standardized estimates right here, these indicator loadings are not exactly equal, but roughly equivalent to these loadings. Look, useful for 0.961. Here it is, useful for 0.93. So these are like the loadings in the pattern matrix. They're not the same because we are now constraining this model, saying that these items belong to this latent factor. And so it's not freely being estimated, it's being estimated in a constrained environment, and so these estimates will vary, and they have to take into account all these covariances. These covariances, well, these are correlations actually. These unstandardized, these are the covariances. But these correlations are roughly the extent to which the latent factors covary. If I were to square this number, 0.49, and get 0.249 something, then that's the percent of shared variance between these two. It's like looking at that correlation matrix down here, the factor correlation matrix. And so, for example, factor 1 to factor 2 was 0.484. Here it's 0.49. So roughly the same thing. So what we want is high numbers here from latent factor to indicator. We want high numbers here, roughly averaging out over 0.7. And we want not as high in the covariances. Typically, if you see something over 0.82, don't ask me why that's the right number, but it is the magic number. If you see something above 0.82 here, you're likely going to have discriminant validity issues. You may recall we had some discriminant validity issues between decision quality and information acquisition. If I go look at that covariance line, 0.73, square that, it's more than 50%. It's almost exactly, no, it's almost 50%. So that's borderline right there. of shared variance. Okay. We also have error terms. You notice that anything with a single-headed arrow going into it has to have an error associated with it. Whenever you are predicting something, there is an error associated with it. So that's why they have errors. If the arrows instead were going towards the latent factor would have to have an error term on it. But that wouldn't work, so we're not doing that. Any questions about the model in general, how it makes sense?
How do we fix if we have high correlation?
Let's look at that. If you have high correlations between two latent factors, that's going to show up as a problem in your discriminant validity analysis, which we're going to do next. In fact, let's run a discriminant validity analysis and see if we have problems. My guess is we won't in this model because we fixed it all in EFA, but let's check. We go to the output, which is the view text button right next to the save button. Go to the estimates, scalars, and we're going to take a couple pieces of things from here. I'm going to go to the correlations matrix first. Now, in order to the next steps, you'll need the stat tools package, which is available on the stat wiki. I don't think it's the most recent one, though. Maybe I should give you guys the most recent one. It all works roughly the same. Let me just stick it in the folder. How about that? In the BYU SEM Boot Camp. Oh, there's one. I bet that's old, though. Let me delete it. There we go. Okay, you guys now have the newest, not available online, premium, exclusive stats tools package in that Dropbox folder. You'll need that for these next few analyses. Let me back up a little bit. Why are we doing a CFA? It feels a little bit like TurboTax right now. Just push buttons, enter numbers, push buttons, click here, go there. The CFA is to confirm what we discovered in the EFA. It gives us additional information on the validity of our measures beyond what the EFA can give you. So that's why we're doing the CFA. It allows us to check things like model fit, which I haven't explained yet, invariance, which I haven't explained yet, method bias, which I haven't explained yet, which we'll all do today. Okay. So here we go. Open up that stats tools package. Well, drag it onto your computer and then open it. Has a bunch of tabs. You want to be in the validity master tab. Now, I made these tools a long time ago, mostly during lunch breaks while learning this stuff. So they're really dirty. If you know how to program in VBA, which is the language I'm using, please don't look too poorly upon me if you look at that code. It's very bad, but it works sometimes. Okay, what you do is go to the Amos output. Again, estimates, scalars, correlations. And you're going to left-click on the outside here and right-click it to copy. You can't click inside to copy, or else it won't work properly. And you're going to paste that correlation matrix in A1. If you're on a Mac, this might not work, even if you're in Windows. If it doesn't work, sorry, follow along, or watch and follow along later. And then you want to go get the standardized regression weights table. Left-click, copy, and put it in F. Just like it says in the button. Paste correlations table in A1, standardized regression weights table in F1, then click me with several caveats. I get at least an email a day saying it didn't work. I said, did you read the caveats? No. Works every time if you read the caveats. Oh, no validity concerns. Woo! This should always happen. You should always end up with no validity concerns if you've done a good EFA, or if your EFA was able to resolve properly. But let's say we didn't come to a good end. Let me mess it up for a bit. And I didn't explain that table. I'll explain the table in a sec. Let me mess up our model a little bit. I'm going to add to decision quality. A couple more are those ones that didn't work. Let's see, decision quality 6 was awful, I believe, and 13 was awful. There we go. Get rid of these labels here. Okay. Give these error names. Let me just use the plugin. Plugin name unobserved. Hope you're not following along, you're just watching for this part. So this should mess up our model. We should now have a discriminant validity issue between decision quality and information acquisition. We run it. See, no, not plugin, sorry, up arrow. And we're now at 75 here. Let's see if that messes things up. I'm just going to go rerun the validity master. Copy. Hit reset. Paste this in here. You can't believe how difficult and time-consuming it was to get this. Dang it, it worked. To get something like this, every time you had to rerun your model. And every time you move an item in or out, you have to rerun your model. Ooh, anyway, you're spoiled. Okay. That didn't work. Let me make it worse. In fact, I can just force it to be awful. I will get rid of a few things. Yeah, that'll really mess it up. There we go. Let me just see if this one works before I really foul it up. Yeah, that might do it. All right. Estimates. See, when you do a good EFA and you do good data screening, you should end up with no problems in the CFA. Every time somebody contacts me about the CFA having problems, I say, did you do your data screening? How was your EFA? Oh, well, I just jumped straight to the overflow and didn't work. Nice. Oh, that's what, yes?
I just ran that and I've got that problem using the little capstone data set. Because I put ID1 back in there.
Yep.
And it's giving me validity concern. So if you find something that doesn't work, I can see.
I unfortunately I cannot do that one.
So let me ask you a question differently.
Yeah.
There we go. Now we have issues.
So what happens when you have validity concerns?
So what's the problem?
I mean, I follow the same steps.
Uh-huh.
I put the correlations, and I get validity concerns, reliability. The CR for this factor is less than 0.7.
Uh-huh.
And conversion validity for this same factor is less than 0.5.
Okay. Very close. Let's talk through it. I'm going to talk through these couple, and then I'll talk through what happens if you have convergent validity issues. In fact, I could create some real quick. Last run on this, I'll create some convergent validity issues here. Right here, let me throw in something bizarre like I'm just going to mess it up really bad, like this. There we go. That is just going to destroy things. This is going to mess it up real good. And then we'll have both convergent and discriminant validity issues. And we'll explain how to get through both. It won't even run. All right. Darn it. Okay. Here's what we'll do. Sorry about that. It's because it has missing data. There we go. Oh, yeah. Now let's run it. It might still be conversion. No, that won't be conversion. Excellent. Okay, here we go. Thanks for bearing with me as we work this out. It also gives you time to catch up. Copy over to Excel, paste, and regression weights. Copy, and paste. Again, we should have both issues. Here we go. We have all sorts of issues. Yes?
Well, I'm just having problems. I'm having an error that's coming up that says unhandled exception is a premier component of application. Application will there.
Did you try using the plugin? Is that what caused the error. Yeah, it's your .NET framework. It's the programming environment where the code runs. It needs to be updated, so you won't be able to use that plugin for now. Sorry. Oh, really? Oh. I wonder if Windows updated recently. Maybe. Okay. Well, I can look at it during a break. Okay. All right, we have conversion validity issues, reliability issues, discriminant validity issues. This is a mess. This is what you will often see if you don't have a good EFA or good data screening. So let's take care of these in turn. What does this even mean? The correlation matrix is found here. This is just the correlations found over here, put into a matrix form. And then on the diagonal, we have the square root of the AVE, which is the average variance extracted, this column. According to Fornell and Larker and a few others, you need to have, for discriminant validity, your square root of the AVE be greater than any other correlation with another latent factor. There are good reasons for this. What this essentially means is that no other factor is explaining more variance in my items than my items are. So we have some issues. This one right here, decision quality. That square root of the AVE is less than this correlation. So by a long shot. So how do we fix that? We have to increase discriminants between those two, between decision quality and information acquisition. So just like in the EFA, where I took those separately and stuck them in their own EFA, that's what we'd need to do at this point. We'd go back to the EFA. We'd run a separate EFA on just these two. And then we'd try to increase discriminants between them by removing cross-loading items, one at a time. And then we'd run back to the CFA and try to do this again until we could get discriminants. What if we can't ever achieve discriminants between them? Discriminant validity is very important, because if you don't have discriminant validity, you can't know if your two latent factors are actually two latent factors or just the same factor in two different places. And so if you start trying to predict one factor with another factor, but they're not discriminant, you end up in what's called a tautological relationship, where you're trying to predict something with itself. So
That's bad.
that's bad, because that's completely atheoretical. That's saying, I know what gender you are because of your anatomy. Your anatomy predicts your gender because you are your gender because of your anatomy. It's the same thing. It's very accurate, but completely like, yeah, duh. I mean, there's no interest to it. So you end up with a tautological relationship, and it becomes completely unimportant, non-significant, or insignificant in this case, and uninteresting. So you want to go back to the EFA and try to separate those. Yes, Henny?
Isn't it time to make an executive decision to go back on this construct and to identify the lowest crumb on it and to remove one of those items that is creating a problem? Because I didn't have this problem without this item. I've added one item and I got into these issues.
And so, yeah.
To get now a decision to get back and remove one item?
That would definitely be a good decision from my perspective. Yeah, you go run the EFA again, and also look at the Cronbach's alpha with item deleted. And if both point to removing that item, boy, I'd remove it.
The Cronbach was better.
EFA was better.
But the thing is, on this construct, I don't have too many items.
Ah, see, that's rough. But here's the deal. I wish I could draw and have everybody see. I can draw. Here we go. Check this out. Let's say the question, I think the overarching question is, what if I have a construct with only a few items, and one of them is causing trouble, but if I remove that item, I only have 2 items left. And that's not stable sometimes. So let's say we had...
Especially when it is also a dependent variable.
Oh, it's a dependent variable. Yes?
I add something to that?
Yep.
Per your recommendation on that point, I emailed Tony last night.
Uh-huh. What'd she say?
And I gave her the pros and cons of both.
Yeah.
She said, leave that item ID 1 can't.
Or else it won't run?
Well, she says it's the old, you don't want
Two items. Okay.
So this is like
Okay. Do what your advisor says. Here's my philosophy. Yeah. Here's my philosophy. You have 3 items on a latent factor. We're going to pretend these are the 3 items. And we talked about variables moving yesterday, right? So let's say this one moves. This is a very blunt approach here, but let's say this variable moves in this direction, you know, and this one moves in this direction, and the third one moves in this direction. But they're all part of the same latent factor. And so by removing this one, automatically we have better reliability, we have better convergent validity, but we only end up with 2 items. Now let's say we want to predict this latent factor. Let me give it, so this is the latent factor that these guys belong to. And we're going to use this latent factor to predict that latent factor. Oh, come on. Like this. Well, what now? I'm using the variance in this guy's items to predict the variance in this guy's items. But if these guys don't move together, it's going to be really hard to predict their variance because there's inconsistent, unreliable movement. Whereas if I remove this guy, take him out of the picture, it's now very easy to predict the variance here. And so my effects will be stronger, my R square will be higher, and it's more likely I'll find significant effects if significant effects exist. So that's my philosophy. The downside, this is now a 2-item latent construct. And 2 items is pretty paltry, very small, very unstable. So it's a trade-off. Yes.
So two questions. One is that if you remove the 3rd item and your reliability is still resulting in about 0.72, 0.7.
That's fine. 0.7s are good.
But it's big.
But it's only 2 items, and so you can accept down to 0.6.
Okay. And then, given that it's a DD, in your conceptual model, your results may actually portray that it's not a DD. And so it can move around.
So oftentimes what happens is when you have a variable that fails, you do end up moving it. Now some people will say, well, you're fishing. No. You had a theory going into this. You can't change your theory just because you saw your stats didn't work. But what if that's your only dependent variable? Yeah, I just collected data and spent a year of my life for something I'm going to throw in the trash, right? If it were me, I'd say, well, let's maybe try this guy out as a moderator or as an independent variable or as it obviously all still has to be theoretically sound. What we're seeking for as scientists is new insights. If our data can give us new insights, they're new insights. We're learning, we're contributing to knowledge. It has to be theoretically sound. Hope that was enlightening. Hope you never have to go through that. What are you talking about? All right. Okay. So with discriminant validity, that's one way to fix it. Go back to your EFA, try to increase discriminants. Another way to fix discriminant validity is to increase convergent validity, because your discriminants is based on your convergence. If you have higher convergent validity, you can accept a higher correlation between other factors. Oh, so for example, the reason this guy fails decision quality is because its convergent validity, as noted by the composite reliability and AVE, average variance extracted, these are too low. Why? Because the loadings on it, 0.72, 0.71, 0.53, are too low. They average out less than 0.7. And so when you square those roughly, there's actually a few other things going on in there, but when you square them roughly, you get less than 0.5, which is the threshold for AVE. But if I can increase my convergence, let's do that real quick. Let me increase convergence, down arrow, by throwing in a proper variable. Let's see, we have 6 and 13 I threw in there. Let's go 7 and 8 and see if that helps. Just run it before I try to fix things here. Up arrow. There we go. 9, 1, 8, 7, 6, 7. Will I still have a discriminant validity issue? I haven't even addressed discriminant validity. I've only touched convergent validity. And now let me go test it. see if just addressing convergent validity can fix issues with discriminant validity. Back here, reset, paste. Paste. And look at that, it fixed everything. By fixing convergent validity, I was able to fix discriminant validity.
What did you say just again? Can you go over that again?
Yeah.
I didn't follow.
Yeah, so when you have a, I wonder if there's a way to draw this. There is. And since I'm remote right now with people, I got to do this digitally so everybody can see. I can't just do it on the whiteboard, unfortunately. But let's say you have these guys representing your latent factor, right? Control D and color them because I'm pretty OCD. Okay. These are your two latent factors comprised of many items each. And you have some convergent issues with this blue guy, right? And because you have convergent issues, there is a discriminant issue between the two latent factors. You can fix this discriminant issue by cleaning up your convergent issue. If I just lop this guy off, whoa, all of a sudden, I'm both convergent and discriminant. So applying this directly, we had low loadings here. If I can increase these loadings somehow, then that makes discriminant validity not even an issue. Because the idea is I want these items to be able to predict each other more than these items can predict them. That's the idea between convergent and discriminant validity. If more of the variance of these guys is explained by these guys than by each other, then you have a discriminant validity issue. And so if you can just make these guys tighter somehow, more closer knit, higher loadings is what it translates to, then this isn't even an issue. The discriminant validity is not even an issue. So you can fix discriminant validity by addressing convergent validity. Often the way to do this is to go back to the Cronbach's alpha if item deleted in SPSS and lop off the bad one.
But we cannot have an exception if we have 0.675 and our threshold is at 0.7.
For which measure?
For the reliability.
For composite reliability or for Cronbach's alpha? They're both the same at 0.7.
I mean, for the same, for the Excel sheet that we have.
This one? Yeah, so that's 0.7.
Yeah, and then I got 0.675.
So what I would say there is if it's less than 0.7 on the composite reliability, see if that's for a latent factor that has 2 or 3 items. If you have 2 or 3 items, you can accept a lower reliability value. Here's another issue that often comes up. I have a good CR, composite reliability, but I have a terrible AVE. Not terrible. It's like 0.47. There's a paper, it's Malhotra and Dash, 2000, I think, who say that AVE is a very strict measure of reliability. And so you can establish reliability based on the composite reliability alone, even if your AVE is not above 0.5. Okay. I know this is like lots of stuff coming at you. So feel free to ask questions. We fixed discriminant validity. We fixed convergent validity. How do we fix reliability? By fixing convergent validity. They are almost calculated the same way. If you can fix your convergent validity by increasing the loadings somehow, by lopping off an item that doesn't belong, then you'll fix your reliability issue. And often the best way to do that is, again, to go back to SPSS and look at analysis, scale, reliability, and look at the Cronbach's alpha if the items are deleted. Yes?
So getting back to this argument about you can go forward with only 2 items in there. The only way to fix this that you were describing is to lop off
the bad item.
that gets you down to two items. So can you proceed if you're getting bad validity numbers, bad meaning below the threshold, but you're saying, I got to keep that item in to have 3 items. Can you just say, the heck with what my validity number is telling me, I'm going to push forward anyway? Because it's like you're between a rock and a hard place with the problem.
You are. Let me repeat the question for the remote folks. What are you sacrificing, essentially, by retaining a bad item, and in order to have 3 items instead of 2 items? And it sort of goes back to that drawing where you're trying to predict. As soon as you start drawing causal models, you're trying to predict something that is not consistent, which is the real issue. You don't have a consistent latent factor. The reliability is low. It is hard to predict something that's not consistent, right? It's hard to predict the behavior or the variance in an inconsistent latent factor. And so what you're going to find is nothing can predict it. There will be no significant effects is the most likely scenario. Now, what do you sacrifice by losing that item? Well, you risk instability, especially as you move on to common method bias tests. As you introduce, what is that, 40 new parameters in a common method bias test, you can become very unstable with only 2 items.
What do you mean by unstable?
The model might not run. Yeah, it'll say it can't converge. There's no good solution. And so what do you do at that point? Now you're between a rock and a hard place. At that point, you ask your advisor. And my advice would be to run a different method bias test that doesn't require all those new parameters. But what are you to do? For this particular situation, do as your advisor says. But in general, these are my thoughts. Okay. Moving forward. I'm going to go back to my original model that was clean. Here it is. All right. I'm going to go to the slides for a minute to see if we've covered some stuff, and then we're going to take a quick break to let our brains cool off. So we talked about how that works. This is for confirming factor structure. We talked about that, talked about that, and that. I didn't talk about those 2. Real quick, maximum shared variance and average shared variance. In the past, these haven't been a big deal, but more recently, hang out, folks. I'll get to you in a sec. I heard that text. More recently, it's being argued that maximum shared variance versus the AVE is the only true way to establish discriminant validity. So I should talk about it. Maximum shared variance is, I think I might even, oh, here it is. Okay, maximum shared variance is the amount of shared variance between, it's the covariance, essentially. You square the correlation here, and you get your maximum shared variance. Now, that's not right. It's the exact value in this case. Let me double check that. I want to make sure I'm not telling any lies. Maximum shared variance between with decision quality is 680. If I go to my model, hit the up. Oh, that's an old one. Other. Well, roughly, it's the amount of variance explained by some other latent factor. And in our case, we want to have things less than 0.8, roughly, in these correlation lines. And you want the amount of variance explained by another factor to be less than the amount of variance explained by my own factor, which is the average variance extracted, AVE. And so the MSV has got to be less than the AVE. Let me show you where that is. And here's your MSV, maximum shared variance, has got to be less than average shared variance. This is the variance explained by another factor. This is the variance explained by my own factor. So we got to explain more variance for ourselves than by someone else. Okay, average shared variance is another thing. It's just the average variance shared with all other factors. Don't worry about that one too much. Talked about that. Talked about that. And as a fit, we'll hit next. Okay, let's take a quick break. Whew. Here I come, remote folks. Okay. During the break, can you send me the Bootcamp 1 file you'll find on Dropbox? And oh, you got it. Good. You're welcome. Excellent. Thank you. All right, we're gonna take a quick break, guys. That was a rough morning. Yeah, I'll come up. Hmm? No, here I come. My feet are pretty good today. Some days they hurt, some days they don't. No, some mornings they hurt, some minutes they hurt, some minutes they don't.
Okay, well, hopefully we'll get you that. So this is up to us, but just do some quick experimentation.
I've never had a problem with this before. It's so weird.
We've played with this. And I've tried this.
So I think I had something similar to this happen before, and I just replaced the driver, and I don't know if that corrupted somehow, or
they're known. Just control C. See if it's not funded. So let's go back. Can you break it up? Yeah, there we go. Alright, so Amos fast.
So I have it's the third one. And I wanted to delete it and then see if we can.
Worked? Oh, yay! It's good when it works. Can you imagine doing all these calculations? You're using all this data. So I had an earlier tool that did sort of step-by-step, which was way better than the way we were doing it by hand. But boy, this is, you run 1,000 miles. My email notice if we don't. Might be. What I like to do though is try to plug in this. I have one, it just doesn't. But really, they are. They've just they don't even. Sometimes they update it to get a version of it. But the last 3 updates, they only changed the backwards steps and eventually make it cool. There have been no functionality changes. So they need to add plugins to Did you want it first?
Yeah.
Nope. Sorry. It was very interesting. I thought before you stick that in there.
Oh, really?
Yeah, weird. Unblock it when you download this folder. Whatever it is, there.
I don't know. So I wonder if I was running in 22. Like, yeah.
I don't know if it's 23.
Okay.
So I just tested it.
And I think it can. Yeah, I've run it before. I'll show you. I've run it before with your nice little plugin. It's wonderful.
Anyone else have a question you need me to get? Okay.
Yeah.
Oh, wow. I'm gonna grab a granola bar. Well, just in case it's happening.
Well, this is not.
It's working on your computer all the time. Well, yeah.
No, what I did is, but because I copy it, right.
You lose that model function to rebuild it. So, opening reading the data. Let me know. So,
Okay. Off the store. So from here, we're trying to bounce into that. So, you know, understand where is that? So this, right? Okay. So we were using.
Correlations.
So when we.
More.
Okay, more.
Because one of the caveats is complete variables have to not use.
Okay, so that's.
So I heard that's not an indicator in some.
Oh, because I didn't change that because I had to shut the whole thing down to do that. Okay.
Anyone else? And then we start. We'll get started in about 2 minutes. There's already a diagram in there.
Yeah.
We'll probably get upset with that. Just thinking.
Well, it's a leak in the last one. Anyway, that's the result. I get the one just fine. I think it's zeros.
We do estimating means intercepts. You're not supposed to. Only if you're using data. No. So you can, in the analysis properties, color application, any estimation data, there's a checkbox that says estimate means intercepts. Uncheck that. Uncheck. Yeah. Great. Okay. So, last one, right? No. So you have to force it. Close it. So leave that just again. So you should do those things. Like I did in initially, you make a late factor and you try to go with it. It's just
I guess is that it's something to do with having. It's just very corporate. So it's not. Okay, let's get started again. Yes.
For our correlation table that we're trying to paste over into the tool, we're just putting latent variable correlations to every item.
Yes, that's correct.
Is that what this is?
Okay. Here we go. We made it, barely, to model fit. Okay. Woo! CFA is big, like I mentioned. One of the most important things in your CFA is to assess model fit. I gotta sort of explain what model fit is. Essentially, model fit says what are the major relationships between all the variables in the model you're showing right now, and then are you accounting for all those major relationships? In a CFA, which relationships are we accounting for? Just the relationships between items in factors. And so if these are the major relationships, which is usually indicated also by convergent and discriminant validity, then we're good. But if, for example, decision quality 8 is highly correlated with playfulness 6, then that's some major relationship we're not really accounting for. And so our model that we've drawn doesn't fit the data. That's what's meant by model fit, is whether your model fits the data. And so that's something that needs to be assessed in a confirmatory factor analysis. How do you do that? You run it. Oh, you know what? I think this is my old model. I'm going to have to go fix the... No, that worked. Okay, cool. You run it, and you go to the output. And I wonder if there's a way to increase my font size. Probably not. Column spacing, decimals. No, I don't think there is. Okay. Oh, there is. Look at that. They fixed it. Okay. Estimates. Nope, where it is. Model fit, excuse me. You want to go to the model fit section down here at the very bottom. I'm going to explain what some of these numbers mean. Also, if you ever want to know what something means in Amos, if it's highlighted, you can click on it, and it'll tell you all sorts of stuff and give you references, which is pretty cool. It even interpret values for you. Okay, so you're going to have to just sort of take my word for it on some of these things, what each measure is and what the threshold is that we're supposed to meet. I've written it down here somewhere in these slides. There are a bunch of slides about what the thresholds are and what we need to meet. So in order to assess model fit, we have to have a C-min, which is actually your chi-square. I don't know why they name it something different. It's your chi-square divided by your degrees of freedom. We want this between 1 and 3. We talked about this yesterday with the EFA as well. So we're good. It's between 1 and 3. That's awesome. These are your degrees of freedom. This is your chi-square. This is your p-value for the model. It's your chi-square p-value. This is the backwards one where you... No, this isn't the backwards one. Is this the back? This is the backwards one where you want it to be not significant, just to confuse you, right? You want this to be not significant, which means you don't have poor fit. It's sort of a triple negative. So in this case, this indicates that we might have poor fit because it is significant. But the chi-square is exceptionally sensitive to sample size and the number of parameters in your model, like the number of variables and lines and stuff. And so we have a huge sample. We have almost 400 sample size, which means our chi-square is going to be very large, 1,310, which means our p-value is never, almost never, going to be non-significant. So in a case like this where you have more than 300, sample size more than 250 probably is a good threshold. I don't know for sure. I wouldn't rely on this p-value too much. I wouldn't hold yourself to it. I'm going to skip right down to the CFI. Some of you probably see the GFI and wonder why we're not hitting that. Sort of an older measure, less robust. The CFI should be above 0.95, ideally. For large sample sizes, we can actually accept, and for large sample sizes and complex models, we can accept a lower threshold of 0.9. There's a table, chapter 12 of Joe Hare's book, Multivariate Data Analysis, version 7, 2010. In chapter 12, I think it's table 2, he talks about which thresholds for which sample size for which number of variables we can accept. And I might even have a copy of it. We'll see in the slides. But again, 0.95 is what we're looking for in general. I'm going to go down to the RMSEA. And here we want an RMSEA, depending on who you talk to, less than either 0.1 or 0.8 or 0.6. Again, depending on who you talk to. But no matter who you talk to, we're good. We're at 0.052. That's great. And you want a P close of greater than, again, depending on who you talk to, 0.05 or 0.5. Again, depending on who you talk to. I'm happy with greater than 0.05.
Okay.
Yes?
Can you explain the difference between P close or
there is a difference, yeah. I'll try to explain the difference. The P close is the probability that your RMSEA falls within the confidence interval, the low and the high here. And so this falls outside of, the confidence interval here. And in our case, it's not significant, therefore it is very unlikely that it falls outside of that confidence interval. The P for the model is a significance test for the chi-square. And if the chi-square is significant, that means the observed versus estimated, so the actual data versus the model we put in there, is significantly different. The model does not fit if it's significant.
But yet, you said earlier for a larger size model, what I heard is don't worry about.
Yeah, for a large model with lots of sample, the chi-square p-value is not reliable.
What's your definition for?
More than about, well, for sample size, more than about 250 is my guess on that one. For number of variables or parameters, I'm not sure. I'd have to think about that.
Sample size big.
Yeah. Okay. Those are the big ones. And that's just a bunch of numbers and thresholds thrown at you. I have a table of them down here in my slides somewhere. Here it is. That says what each thing should be. And I have these other GFI, AGFI, SRMR. I should show you where to get the SRMR because it's not intuitive at all. But let me explain why I chose these three first. Because there are a dozen, at least, measures of fit. And I only use these three. Other journals use others, so you got to tailor your analysis to which outlet you're publishing in. But I choose these three because there are three different perspectives on model fit. One is an absolute perspective. Regardless of sample size and model complexity, the chi-square is absolute. The CFI is a relative perspective on model fit. So that takes into account sample size and model complexity. And then RMSEA is a parsimony adjusted, meaning, and so this is more relevant to causal models, but it works here. If you've added a bunch of parameters, a bunch of lines, just haphazardly, your parsimony adjusted measure will suffer because you've thrown in a bunch of stuff that doesn't need to be there. So it's not parsimonious, which we'll talk about. With that in mind, I'm going to go back through some of these slides. Okay, and then I'd love for you to ask questions as we go through if this doesn't make sense. Okay, so measurement model, structural model. We're going to talk just about the measurement model fit. We did this slide. I'm going to skip this one. I'll talk about this. Okay, this is a causal model, your structural model, but this is applicable to the concept of model fit. Again, model fit says to what extent does the model I've drawn match the data, fit the data. And if you are missing some major relationship, like from confidence to sales ability, see in this first model, I don't have that line. That is a major relationship, 0.55 on the standardized regression rate. That's huge. I'm not accounting for it in this first one. And so my model does not fit the data because I'm missing some major relationship. And so things will suffer. You'll notice the R square, top right here, is 0. But over here it's 0.3. That's way better when you account for that major relationship. These two effects are artificially inflated at 0.56 and 0.64, whereas over here they're 0.47 and 0.54. But notice, even though they're lower here, I get a higher R square because now I'm fitting the model a little bit better in my adjusted model here. So that's the big deal. Are you accounting for all the major relationships in the data using the model you have? So, ceteris paribus, which one of these two models should fit better? Knowing everything else is equal. Which one's going to fit better?
I have a question on the prior slide.
Oh, okay.
I've noticed how the second model, you don't have a relationship between attractiveness and confidence.
Yeah.
Purposely done.
That might have been. That was probably unintentional. It's not significant, surely. So that's not going to affect us too much. But yeah, that's peripheral. That's yeah. Sorry, that was not an intentional move. I'm missing this line here. Okay. So which model fits better, knowing nothing else than what you see here? If we're trying to account for all the major relationships. Yeah, B. Model B fits better. Why? Well, because we're accounting for more major relationships than Model A.
And you're also making that error there.
This was intentional. This was intentional, yeah. We are missing a major line right here, which probably would improve our model fit. But just looking at the principles here, if I account for bigger relationships, I'll have better fit than if I account for smaller relationships.
So will our MSCA drop if we, like if you go back to the other slide?
Mm-hmm.
So it's, so if you look at the 0.05, if we drop that, will our MSCA increase because we're decreasing the path?
Ah, okay. So the question is, if we remove a path that is not meaningful, or that is not significant, will our parsimony adjusted measures improve? The answer is possibly, probably. There's actually the next slide. It is. We should talk about this. Definitely, we should talk about this right after this slide. So which one of these models will have better model fit from an absolute and a relative perspective? Model A will. We're accounting for more relationships. We're accounting for more of the variance in the data. But from a parsimony perspective, Model B. Oh, yeah, that's pretty fancy. Model B is the better model, assuming we haven't missed some major relationship, right? So the question is, let's say we have some non-significant relationships like this one up here. This attractiveness to confidence. What about attractiveness to sales ability? Neither of these are going to be significant. There's not a chance. So are we justified in just dropping that variable or dropping one of the paths? There are different schools of thought on this. Here's my school of thought. If you're theorizing about the effect of one construct on another, and you find that there is no significant effect, that is a finding in and of itself. Because theory dictates that there's a relationship. Your data says, no, there's not. So either there's something screwy about your data or your context that needs to be explained, or your theory needs some adjusting. And so that should be discussed in your paper. Now, what if you run into the problem that you have 0 degrees of freedom and you have non-significant effects? Can you remove one of those non-significant effects to free up some degrees of freedom, or to increase degrees of freedom? If you're going to do that, I would report the terminal effect before you delete the path. So let's say I delete this path because I need a degree of freedom. I would say the terminal effect before deleting it was negative 0.05, and the only reason I deleted it was because I had to get another degree of freedom in order to increase the reliability of my model fit statistics. Not increase the goodness of them, but increase their reliability. Because the more degrees of freedom you have, the more reliable your model fit statistics are. Hope that made sense. If not, please ask questions. So, to summarize, test your theorized model. Don't just delete paths willy-nilly if they're non-significant. In some of my older videos, you'll see me deleting paths just because they're not significant. I'm not testing any theory in those videos. That's why I do that. But if I were you, I would keep all paths you're trying to test. Otherwise, people say, well, you didn't test your model. Okay. We talked about this. Look at these values. These are those two models I showed before. The C-min of DF, when I'm not accounting for confidence and sales ability, awful. It should be between 1 and 3. This is awful. CFI, awful, less than 0.95. RMCA, just awful. That's way more than 0.1 at the liberal threshold. Whereas if I account for that relationship, all of a sudden everything is all hunky-dory. It's all fixed. Okay. And then these are all just FYI. Any questions about degrees of freedom? I know that's not a really super well understood term. By me, apparently.
We all know about, we don't actually know what it is.
Yeah, okay. So degrees of freedom, let me show you. Degrees of freedom is essentially the number of parameters. A parameter, I get to define a parameter. A parameter is a line in Amos. It's a line between two variables. So a degree of freedom is essentially a parameter you could have included but didn't. If you include all possible parameters, like in that model we had up here, this one, the one on the left, has 0 degrees of freedom. Because every possible parameter that could be accounted for is accounted for. Whereas the one on the right has several degrees of freedom, because there are many parameters not drawn that could have been drawn. So that's sort of the high-level view of degrees of freedom. It's the number of parameters we didn't account for that we could have accounted for. And typically, the more degrees of freedom you have, the more theoretical your model is. Because you're saying, no, I don't think this relationship does exist. I think that one does, this one doesn't, and that one does. Whereas if you have 0 degrees of freedom, you're saying, oh, everything predicts everything. Yep, that's completely atheoretical. If you have 0 degrees of freedom, you're saying everything is a predictor of everything, and so that's my theory of everything, which is not a theory at all. Also, model fit is all based on degrees of freedom. And so if you have 0 degrees of freedom, let me show you. Let me save this. Let me show you something. Don't follow along, just watch. If I throw in some data, oops, capstone, don't need that. Any data is fine. I don't care what it is. Let's see. Okay. So I'm going to throw in a few variables here. If I draw lines between, oops, all of these variables, are there any lines I haven't accounted for? Nope, they're all there. Anything that's predicted needs an endogenous variable. I need to name those, and then I need to save this or else it won't run. Just playing around. And let me run it, and let me show you the degrees of freedom. 0. There's 0 degrees of freedom. Now what happens to model fit? I have no C-min or VF because you can't divide by 0. It's undefined. I have no PGFI, AGFI. My CFI is 1 because, yeah, I've accounted for all the variants. I have perfect model fit. My PCFI doesn't exist. My P-close, no good, no good. Because this is parsimony adjusted. I have 0 degrees of freedom, so my parsimony adjusted measures fail. So that's degrees of freedom. Hope that clarifies.
Does parsimony have anything to do with your number of observation points or your number of factors, or is it only just
the parameters? Yeah, the parameters, yes.
All the parameters you could have had minus the ones you could have.
Yeah, so it's all, the parsimony adjusted measures are based largely upon your degrees of freedom. Now, which is just all about the variables that you've related to each other. Okay, cool. We have learned. Degrees of freedom, we just talked about. Determining fit, these are just FYI. I'm not going through these. We sort of talked about it. Oh, here's the reference. It's 12-4. Excuse me, not 12-2. So if you have a large sample size or a lot of variables in your model and you can't achieve good model fit, go check this out. Hare, Chapter 12, Table 4. And they'll show that you can actually accept a CFI of 0.9 when you have more than a certain number of sample size, more than a certain number of variables. I have that book upstairs. If you guys need it during the break, I can bring it down, if that would help. Okay, causes of poor fit. I get emails like this all the time too. My model doesn't fit. Everything else works, but my model doesn't fit. So I asked, did you do data screening in your EFA? It all boils back to that. If you have non-normal data, that's going to affect. Let me just put all these up here. If you have non-normal data, that's going to affect your model fit. If you have a bad EFA, that means you've specified which variables go with which latent factors wrongly, that's going to affect your model fit. If you have first-order factors that really ought to be second-order factors, that's going to affect your model fit. If you have formative factors that are modeled reflectively, because you're in Amos and you don't want to do things formatively in Amos, well, then that's going to affect your model fit. Overspecification we talked about, so not enough degrees of freedom. If you don't have good validity, that matrix we showed, if you don't have good ABE, MSV, CR, that will affect your model fit. And lastly, large sample size and model complexity. So we expect worse model fit in larger, more complex models. And remedies. Oh, let's do this. Okay, what time? It's almost 11. Excellent. We've only scratched the surface. Okay. Let's say I don't have good fit for a moment. In fact, my CFI wasn't 0.95, right? It was lower than that. So how do I fix that? There's this magical thing called modification indices. If you click on the analysis properties and go to the very bottom checkbox in the output tab, it says modification indices. There's also a threshold for these. It's defaulted to 4. We have a very large sample size. These are based on the chi-square, so large sample size can inflate these. I'm going to bump this up to 20 for now, just to see if there's anything over 20. You'll see why. I'm going to close that, rerun this, and go to my output. And there's this thing called modification indices here. If I had left it at 4, then any modification indice over 4 would have shown up, and I'd have this ginormous 100-row list of modification indices. This one just shows the major ones. Different schools of thought on this. Purists will tell you you may not address modification indices because that's not true accounting for variance. That's fiddling. Well, I'm not a purist. And so I feel content addressing major modification indices, not optimizing your model, but getting a sufficient model. Word on this. We have good enough fit right now. It's good enough. We don't need to address modification indices. If my CFI was less than 0.9, I'd go look at these. Ours is above 0.9, I'm happy. Because if you, let me show you how to address them. I'll talk about why this is important. Let's look for the big one. E8 to E13. This says this is some major relationship you're not accounting for. Of course we're not accounting for covariances between errors. That's just weird. But it says it does exist. Between E8 and E13, there is some major covariance that you're not accounting for. Well, let me zoom in here. Here's E8, here's E13 on joy 6 and 7. Why on earth would joy 6 and 7 be related? Or have similar error? Yeah, it is. We go look at their wording, I guess. They're next to each other in the survey. And they're the 6th and the 7th out of 7. If I didn't randomize this survey, and the person's already answered 5 questions about the same thing, yeah, same, yep, same. So they probably put the exact same number for 6 and 7, almost uniformly. And so there is going to be a systematic non-theoretical covariance or correlation between the errors of those two items. It's not something we care about, really. It's just something we need to account for. And that's why we would stick a little covariance arrow between these two. And we know why we're doing it. I think this is the important point. You don't just, again, willy-nilly stick covariance arrows between everything that's in this table. You say, well, why, theoretically, why should this exist? Is there a good reason for it? Can I account for that? If there is, then okay, let me go ahead and account for it. If there is no good reason, I think you're just playing around. Okay, so what you do is you go run it again with that covariance in there and see if you fixed model fit. Model fit, CFI 0.944 were much higher. Maybe one more will fix it. Modification indices, well, next biggest one is 45. E1 and E2, again, they're next to each other in the survey, is my guess. Let's find out. Here's E1 and 2, 3 and 4, useful 3 and 4, right next to each other in the survey. Probably have similar wording too if we want to go look at the wording. So I'd run that. I bet we're up above 0.95. Model fit. Here it is, 0.950 for the CFI. So we're good. Do I keep doing it? I have an opportunity to increase my CFI up to 0.99. No, just stop there. Good enough is good enough in model fit. Yes?
A couple questions on that. When you said a minute ago, only major modification indices. What is your definition of major? Is it 20, number you plug in there, or is it something else?
Totally depends on the sample size. I was working with someone who was using secondary data. She had 10,000 rows in her data. Her modification indices were in the 100,000s. And so if I had set that at 20, I'd have seen everything. So we set her threshold to something like 50,000 because the modification indices is going to change depending on your sample size.
Well, how do you, so based on your sample size, is there a rule of thumb? How would I figure out?
Oh, you just go run it and then see what the biggest ones are and then drop a little bit and then go rerun it with that new threshold. So that's what I would have done here had I not known a priori. So let me take that out, go back to 4, and run it. And we see that I end up with everything in the kitchen sink. I mean, there's a lot of modifications. And so I go look at this and be like, I see some 15s, 20s, 20, 30, 30, 40. I'd probably cut it off at 15 or 20 for this one. 15 might have been the smarter move, but we were already so close to good model fit that it wasn't a big deal. Yeah.
The other question I had is you were talking about purists versus non-purists.
Yes.
I noticed just going through your YouTube videos that you are very keen on really what you just said, which is looking at modification.
Yes.
There are some other folks at Case Western that use that school as an example, who I guess must be extreme purists because they really poo-poo modification indices. So if you're going to justify it, is there research out there that I could look at
yes.
that says this makes sense?
Okay, so on modification indices and being a purist, if you're going to do these, like I said, have a good theoretical reason for every additional parameter you enter in. Because, again, that is sort of atheoretical. We came in with a certain theory, and now we're saying, oh, let me adjust that theory in order to get good model fit. So that's the first rule. Make sure you have a good reason. The second is if you want some more authoritative support on that, go to my CFA section at StatWiki, and let's see, Control F, Dave. There's David's website. Dave Kenny's thoughts on modification indices. Dave Kenny is considered a world-renowned expert on this stuff. And he says, yeah, you can do it, but here's when you can do it. So, anybody should accept Dave Kenny's authority, hopefully. So there it is, Dave Kenny's website. If you click on it and you get an error, nice. Dave Kenny respecification. I'll have to fix that link. And he's taken it down. It might just be a server down issue. I've checked it within the last month and it was fine. So might just be a server issue. Okay. Okay. But there's your authority if you need one. More than citing Gasconation videos, you can actually get somebody who's a renowned expert.
James,
yeah.
Before process this modification analysis, would you say in a simple general format, what would be the most important criteria to validate either two errors or two items together?
What is the most important criteria for justifying the covariance of two errors? If you can see why there should be a systematic covariance between them, usually it's based on one of two things. Either the wording is extremely similar, and this will happen even between items of different factors. You may have useful 5 having almost identical wording to enjoy 2. They're just a couple words switched out. And so if the wording is almost identical, that's, I think, clear cause to covary them. Only if there's a very strong theoretical reason. Yeah. The other reason would be their position in the survey. If they're just right next to each other in the survey, that'll often cause a systematic correlation between the errors.
Okay.
Yeah.
Can you covary same error term twice?
Yeah. So if useful 3 was also or E2 here was also strongly correlated with E5. Yeah, I could go E5 to E2 as well. Just know this, the more parameters you're entering into this model that are not theoretically supported, the more trouble you're going to have down the road supporting your theory and running analyses. So you want to do this very minimally. This is a last resort kind of thing. Okay. So in our model, for example, we were fine. So I'm getting rid of these two. We were 0.9 with a very high sample size and complex model. So I'm not going to mess with this because I know it causes problems.
Just to extend that last thought,
yeah.
You made a very good point that the more extras you put in here, the model for whatever reason they're not supported, you're going to have challenges later explaining what all this is.
Yes.
You also said this morning that having strong lack of correlation or lack of correlation is also fine. Is it therefore treacherous and dangerous to carry a middling
model
factor around or model around? Where you're neither extremely tightly fit or well correlated, nor you're not absolutely uncorrelated. You're somewhere in the middle, and the write-up seems like it's going to be, what do I do?
Maybe this isn't the exact question. I'm going to see if I can rephrase. What happens if you proceed with just okay model fit?
Well, just okay model fit, or just okay standardized regression weights, or variance explained, these kinds of things that it's not a spectacular find. Right. It's neither fully negative nor resolutely positive. It's somewhere in the middle.
So that's a tough question to answer. There are different reasons for different things you mentioned. Let me. Getting back to so the couple questions I'm going to answer, and tell me if I don't hit on them. First is what happens if you proceed with sort of just an okay variable, and the answer is getting back to that drawing I made with the different slopes of the lines between items and trying to predict variance of a poor variable. You can't predict something that's inconsistent. It's like trying to predict the behavior of an insane person. Can't do it. It's like Joker and Batman. Never know what he's going to do. So it's hard to nail him down and predict what's going to happen. And so what that means in terms of the statistics is you probably won't find significant effects. You won't be able to predict it. R-squares will be low because you can't explain the variance, which is what the R-square is. Moving forward with poor validities, that you enter into issues of tautology. Are you predicting something with itself? Or are you even predicting something that actually exists in the case of convergent validity? If you don't have convergent validity, you're not actually measuring what you thought you were measuring. And so if you then start trying to predict this thing, You don't know what this thing actually is. And so even if you find a significant finding, you don't know what it is that's significant because you don't know what it is that you're actually predicting because there's no conversion validity. As for model fit, if you move forward with poor model fit, what that means is there's a better way to model the data than the way you've modeled it.
How does it mean that?
Okay. Yep. Here we go. Let's say I conclude based on these two models here. Sorry, this is kind of small. Let me make it bigger. I conclude not doing the second model. I have this first model, poor fit. And I conclude, boy, there is nothing that can predict sales ability. And look at the strong effect of sales ability and confidence on monthly sales. Those are my findings from my study. Well, it turns out there was a better way to model this. And you can predict sales ability, certainly, if you add this little arrow here. And those effects on monthly sales are not as strong as we once thought. These could have even dropped to being non-significant. And so if we move forward with poor model fit, we are acknowledging that there is a better way to model this that we're not doing. And so our findings are completely invalid because there might be something we're not accounting for.
So just to extend that suggests that poor model fit cannot be created from bad items or bad constructs or any of the other possibilities, simply that there's not the right paths drawn.
Almost. Almost. The question for the remote folks was model fit is essentially based purely on the paths drawn versus not drawn, rather than the internal validity of those items. And the answer is it's more reliant upon those paths, the parameters, than upon the validities. But no, if you have a poorly distributed variable, or if you have a lack of convergent validity among your latent factors, that will also affect your model fit. Yeah.
So therefore, your decision tree is model fit is more important as a driver than reliability statistics. Because if you run,
that's like saying the tires are more important than the engine to get from drive your car from here to there.
Well, if you run your reliability statistics, one which has no concerns, one which has concerns, and you look at the model fit results of both those, and in fact the one that has concerns
has better model fit.
Has a better model fit. What's your decision tree? The model fit.
You try to fix them both. It's like again driving without an engine, but you got the wheels. Yeah. All right. This is a heavy morning. It was just great. I hope we're learning stuff. Yes.
Just when this model, so at that moment, you want to go ahead and establish your business before you do anything else, right?
We're asking about order of operations, right? Order of operations. I have taken you out of order just to sort of get you a good feel for the CFA. In terms of order of operations, if you go to the general guidelines, there's an order of operations area. If we go to the CFA, you want to obtain a roughly decent model in the CFA first. Get roughly decent model fit, which is what we have. But this is not the model fit you're going to report. You're going to wait until you finished everything else in the CFA and then report model fit for the final CFA. So we want to get it roughly decent first so we don't try to move on with obvious red flags. The next thing to do is this. And how are we doing? Do we need a 2-minute break or should we press forward? 2-minute break? Yeah, let's do the 5-minute break. Okay, 5-minute break. We're run up against lunch. We'll start at 1/4 after, and then we'll go till noon. Okay. And I'm happy to answer some questions. I don't need much of a break right now. So.
Sorry, plug in 23 versus 22. My state license is expiring in 22, so I got 23. Still working for me, so.
Okay, weird. You got 23. Yeah. Okay. Good to know. I don't have 23. I upgraded.
Yeah, that's what I'm having issues with. Yeah, so I'm trying to work around. And I think what I was doing is I updated it. And I took the right issue. But what I
We can work during season breaks after. What do you like to say?
You screw yourself up when you have a measure. It's actually going to work.
Yeah, 23.
I just have to read that. It's kind of yeah.
There's a rumor going that single space.
Alright, let's get started. We're going to try to finish at least one more topic before lunch. Okay. I think, let's see, we've talked about validity and reliability. Yeah, because we have common method bias after lunch. That's rough. Oh, actually, we're doing pretty good. So if we can finish, if we can do invariance before lunch, we'll be really well set for after lunch. Because the only thing we'll have to cover after lunch is method bias, which is a beast, especially for those individuals in the room who are working on their project right now. And then I have optionally today we can also talk about cluster analysis, which I know a few of you are interested in. So, okay, moving forward. I better make sure actually before we do this that the remote folks are still alive and well. Let's see. James, if the entire CFA is for second order, we don't get a correlation table, then do we just do a CFA correlating the underlying constructs? Oh, so Milagros, hopefully you're here and listening, but you mean you only have one second order factor in your CFA? Question mark? Yes. So then that's tricky. Yeah, there's no correlations. What I do when I have only, not that I ever do, when I help people who have only one second order factor in their CFA, we just look at average variance extracted, which is essentially the squared loadings. If they average out above 0.5, we're pretty happy. If you want, you can use my old stats tool. Email me for it, and you can automatically calculate the ABE and CR in those. Hopefully that helps. Let's see, James, I cannot get the modification indices to run. I have tried it every which way. It seems my data is incomplete. Yes, you can't use negative 99s. That's going to throw things off in Amos. You have to have the missing values as truly missing. I didn't cover this. Everybody should actually hear this part. It's convention in SPSS or other data handlers to include a -1 or a -9 or a -99 or something like that to indicate a missing value. But in Amos, Amos has no clue you've done that. And so they see that on your 5-point Likert scale, you also have a -99. And so the convergence on that variable is just weird because it thinks that's a real number, not a missing value. And so I'm not aware. Anyone here know, can you specify a missing value indicator in Amos? You can in Smart PLS. I don't think you can in Amos. Wouldn't it be nice? Yeah. It'd be nice if IBM kept supporting Amos too. Developing it. All right. So to answer your question, you got to get rid of that -99, and then if you have missing data in your data set, you cannot run modification indices because you have to estimate means and intercepts. And by estimating means and intercepts, you cannot then estimate modification indices. Yes, honey?
But if you have missing data below the threshold, like one item, and then our threshold is 5%. So can we still go, or we need to put anything in this?
Oh, certainly you can run with missing data. You just can't run modification indices.
So I need to go back again to the model and fill in this.
If you don't have good model fit and you think modification indices might help, then yeah, you'd have to impute those values. But if you have good enough model fit, you don't need to run modification indices, and you can keep on trucking. Okay. All right. Moving forward. Garbage in, garbage out. I love this poem. Who knew you'd be learning poetry in SEM Boot Camp? For want of a nail, the shoe was lost. For want of the shoe, the horse was lost. For want of the horse, the rider was lost. For want of the rider, the battle was lost. For want of the battle, the kingdom was lost. And all for the want of a nail. This gets back to this point that we keep asking about. Well, can I move forward with poor model fit? Can I move forward with poor convergent or discriminant validity? Yeah, sure you can. You just might lose the kingdom. It really is in SEM, garbage in, garbage out, and it starts way back, not at your distributions and normality, your skewness and kurtosis, not at your outliers. It starts back before that when you're formulating your survey questions or whatever instrument you're using for collecting data. That's where the shoe in the nail is when you're pre-testing and trying to get the right measures. If you get the wrong measures, lose the kingdom. So I can't emphasize that enough. Pre-test, 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 pre-test. And then all this other stuff, fade away. Won't even be an issue. All right, totally different topic. See if we can cover this. That's a lot of words. Let me talk about it. If you're going to use a multi-group moderator, like we are, we're going to use frequency and experience as multi-group moderators. If you're going to do that, and a lot of people use gender or age or education as moderators, if you're doing organizational research, you use things like industry, market. If you're going to do that in your causal model, then in your measurement model, you need to assess measurement invariance, which essentially is a homogeneity of variance test like we did yesterday with the EFA, saying that this group and this group, they understood the data collection instrument the same way. And so they have roughly equal variances on the items. And so here's the way to do it. If you don't do that, if you don't do that, then moving forward, let's talk about gender. Males answered this way, females answered this way on the same item. Well, then you don't know if you don't know what you're predicting for each one of those genders because it's different. It's not the same. You can't theorize about one thing. This is. Shad, I'm going to mute you. Oh, you did. Thank you. Okay. Okay. So you need to be at least at a high level invariant, meaning not different. It's kind of backwards. You need to be not. You need to be invariant to show that people understood your instrument the same way and answered it roughly the same way. And that'll lead me to something else later. We'll talk about that in a bit. That's pretty hypnotic. Okay, let's go to the data. So here, what we need to do is save a new model. File. Let me save what we have here, and then save as. And I'm going to say CFA Configural. Save. I want to do metric first. There are two different kinds of invariance. Well, actually, a bunch of different kinds of invariance. You have scalar, metric, configural, intercept, all sorts of different kinds of invariance. I'm going to test for two different types of invariance, the most common, at least in my field, to test for, although I've never actually seen a paper where they reported that they tested for invariance. But we do it just to be rigorous and prudent, but not prudes. Okay, I'm going to save I'm actually going to save it one more time. Save as CFA metric, because I want to run the metric invariance first. And for the, that was stupid. Oh well, I'll get there. Okay, to do this, you need to set up your data to handle 2 different groups, so your model will run across different groups. To do that, though, we need to go create our multi-group moderator. We're moderating by frequency and by experience, but in our data set, we have, let me go open the data set. It's not in that list, so I'll go get it. Data, boot camp trimmed. Here we go. So we're looking for frequency and experience. Here they are, frequency, and I'm just going to drag this down so they're in the same spot, experience, double click it, and you'll see here, these 2 guys, they're not grouping variables right now. They're sort of continuous. And so what I need to do is create a group for low and a group for high for each of these guys. The easiest way to do this, who's following along on their laptop and is going to do this with me, because I need to make sure I go the right speed. We're just watching? Cool, it's all being recorded. Okay, here's what you would do if you need to do this. You go to Analyze, nope, Transform, Rank Cases, grab the 2 you want, which is for us frequency and experience. Stick them in there. Rank types. You can uncheck rank. We don't need that. We need end tiles. We need 2 end tiles. This says give me a top half and a lower half. And so this just grabs it at the median and creates a new variable that gives a 2 to the high value and a 1 to the low value, split at the median. Continue.
Hey, James.
Yes.
So you have data that already has a 1 or 2 option.
No, you're good. If yours is already categorical or binary, you're good. Yeah. So since ours are continuous, and we want to treat them as groups, then now we need to create a high and a low. You often do this for age, because it's usually recorded continuously rather than in groups. Hit OK. You'll see we have 2 new variables over here, and experience and frequency, where 1 is low and 2 is high. And we can even go see if we have a pretty even split. If we go to frequencies, go to the bottom, grab these 2. We just want to see if we have a roughly equal split. And so for N experience, it's splitted at 54%, 205 in the low group, 172 in the high group. And frequency was even better, 195 in the low group, 182 in the high group. So that's pretty cool. Now, you have to save that data again, otherwise it won't work in Amos. And you have to go re-link the data. So double click it, it's the same one, data, this one, and OK. So now we have those 2 variables in there. Just to triple check, it's down at the bottom here, and frequency and experience. And what we'll do is we're going to double click group number and rename this to low experience. And then hit new and create another group called high experience. And then close. So we now have 2 groups, but each group needs data. And so you should go link that data the same way you did before. It's already linked to the first group. The second group needs that data, so go find it. Yes? I'm just going to do the 2 at a time. Yeah. For configural invariance, you have to do it just the 2 at a time. You can't do all together.
So it's not correct to have another category having all combined?
Yeah, I wouldn't have low experience, high experience, low frequency, high frequency for my configural invariance test.
And I can have low and high and then one other category.
Yeah, all could work. I'd keep it just with the 2, personally. Yeah, if you split your multi-group moderator into multiple groups, more than 2, yeah, you do low, medium, high, or whatever, lowest, highest. Yeah. Now, you also have to, in the low experience group, say there's a grouping variable, which is at the bottom for us. We're on experience, so N experience is the grouping variable, and the grouping value for the low group is 1. And you see there are 205 people who answered 1. Glad this is being recorded. These are a lot of steps here. You just do the same thing for the second group. It's group 2. And now we're split. You see 205 out of 377 are in one group, and then the other one. Hit OK. We now have 2 groups. We can just run this regularly, and you'll see if I hit the up arrow, there it is. This is for group high. These are the values. For group low, here are the values. Kind of cool. So we can just toggle between those. In the output, it's the same way. If I go to the output here, there's a high and low. Let me go to estimates. So these are the estimates for low right now, and now switch. Those are the estimates for high. Then you can either delete one of the groups and then respecify that there's no grouping value variable, or just exit and don't save. Yeah. Okay. So this shows us we can sort of eyeball it and see, do we have good loadings for both groups? But there's a formal way to do this, and it's through an invariance check, a metric invariance check. The way to do it is in your output or your analysis properties, go to critical ratios for differences. Actually, 2 different ways to do this. There's the hard way and the easy way. There's the hard imprecise way and the easy precise way. Unfortunately, the hard imprecise way is the most common and accepted way. The easy precise way is hardly published whatsoever. I'm trying to get a paper out there on that. It's hard to convince people that we should do things the easy way, the more precise way. It just blows my mind. Okay. So I hit critical ratios for differences. I run it, go to the output, and I have this awesome matrix that I get to search through for all the critical ratios, the z-scores, for what I want. So instead of doing that, because that's stupid, go to the Group Differences tab in my Excel sheet and go copy. You can copy this over, left-click, right-click, copy, into the critical ratios area over here. Go to your estimates, scalars, regression weights, not standardized regression weights. And this is for the low group. Left-click, right-click, copy. That's group 1. Then you got to make sure to switch groups. Go to the high group. And then left-click, right-click, copy. Paste it. And make sure you fulfill the caveats there. And it just searches for you and gets all these values. Let me make it pretty because I'm OCD. There we go. Oops. Okay. And here's what we end up with. You have group 1, low experience, group 2, high experience. The estimate, that's the unstandardized regression weight, and the p-value for that estimate for both groups. And then you have a z-score, which is a critical ratio that represents the amplitude of difference between, for example, for this row, is the amplitude of difference for the estimate between useful, the latent factor, and its indicator, useful for group 1 and group 2. Are these different, is what it's asking. To what extent are these 2 groups different on this one path? This one path right here. And the answer is they're not different. A z-score less than 1.96, absolute scale, is not significant at the 95% confidence level. So I've flagged significant ones. And this is, you see that's less than 1.96 absolute scale. That's at the 90% confidence level. What we want to see in an invariance test, a measurement model invariance test, is no significant differences at the 95. So this one doesn't really count. This one does. This one definitely does. That's at the 0.01, 99% confidence level. Looking pretty good, not an issue. So we're not perfectly metrically invariant, meaning between the low experience group and the high experience group, there were some differences in their variance on these few items, on item enjoy 3 and enjoy 4. What do we do about it? We say we were not perfectly metrically invariant. We are partially metrically invariant, which is good enough, and there's a reference for that somewhere. Email me, I can get it to you. I can't remember it off the top of my head. And I don't think it's in the slides, but I can get it to you. But there's somebody who says, as long as your latent factors, so for example, there's one latent factor for enjoy, as long as at least one of the paths is not significantly different across groups, then you're cool. You're partially metrically invariant, and that's good enough. So the z-score is it's a critical ratio to represent the amplitude of difference between the two groups for this path or for this path. So let's pick this one here that is significant. This one says that between the low group and the high group, there's a significant difference for the indicator regression weight from enjoy to enjoy 3. We can even see the difference here. It's 0.656 for the low group, 0.867 for the high group. Unstandardized.
So that particular item was a better indicator for the high group?
It's a stronger indicator for the higher group. Yeah, good call. Yeah, and so you can see those differences. Again, emphasize these are unstandardized. We'd have to go look at the standardized to get the relative amplitudes. So standardized 0.916 on, let's use useful 4. No, let's use one that was significantly different. Enjoy 3. Here's enjoy 3. It's for the high group 0.872, for the low group 0.790. Not that different really. But we have a large sample size, so even small things can appear significantly different. And again, why are we doing this? Because we need to demonstrate that our instrument was understood roughly similarly for both groups. Okay. We have time. Last one. You also need to demonstrate configural invariance.
James, I have a question.
Yes.
What if we hypothesize that the groups are going to respond different from each other? Is there a problem?
The problem, yeah, the question for those who didn't hear, what if we actually theorize that these groups should respond differently? Typically on a latent factor, you don't want the variance to be different. It's not that they responded so differently, it's that there was different levels of inconsistency in their responses. So these are looking at the variance differences, not the absolute value differences. So even though, let's say, for example, men enjoy using Excel because they're crazy more than women, then they would have answered higher values. If we did an ANOVA or a t-test, we'd see that the average response value for males was actually more than for females. Does that mean they're invariant? No, that just means that their responses were different. They may have understood the same, and so their level of consistency in response, the variance, would be different if they're variant. That's a subtle distinction.
All right. All right. Thank you.
Correct. What we're trying to see is if they're interpreting the item in similar ways, and the way we sort of use a proxy for that is if the variances in that item are consistent between the two. Yeah. Kind of a roundabout way of doing it. So, but some journals require you to do it, so now you know. There we go. And then there's one other way, the configural invariance. This way is tricky. Yeah. No, we'll do the easy. We're going to do a higher level way for this. Okay, to do a configural invariance, let me save this again as the configural invariance. Save as configural. Save. Yes, replace it. And then what you can do is plugins, name parameters. This is how you do all of your other invariances. There's scalar, intercept, a bunch of different invariance, means invariance. But we're going to name the regression weights. What this does is it forces regression weights from one group to the other group to be equal. And we're going to force them to be equal and then test their model fit. If the model fit's still good, even when we force them to be equal, well then we are invariant. Oh, name parameters. You're going to check the box for regression weights, hit OK, and notice it named them all, and they're the same name across groups. So low group, high group, they're the exact same name, which in Amos tells it to force them to be equal on the unstandardized estimates. And then again, if they have good model fit after being forced to be equal, well then we're good to go. So I'm going to run it, check out model fit. It is going to be poorer than it was, but is it too poor is the question. 0.107 for the C-min over DF, that's great. The CFI, 0.913, still great. The peak close is 1. Wow, that's really good. But that's because we're constraining that, that's why. And the RMCA is 0.043, also great. What if we weren't great? That's the question, I guess. What happens if it's not great? Well, then it gets really difficult. What you have to do is one by one, I hope you never have to do this. This would just be miserable. One by one, you double-click this little arrow, go to parameters, uncheck all groups, then go and we're on the high group right now, and we're going to rename this W1 high. Now notice, since I didn't do it for all groups, if I go to the low group, it's still just W1. And now these two are no longer constrained to be equal. And I run it again and again, one by one, until I find out which stinking item is causing the configural variance. Good. Consider yourself blessed. You should never, ever want to do this. But if you don't achieve configural invariance and your reviewers or whoever is looking at your paper says, well, you need to find out what's the cause, because if you don't achieve configural invariance, that means we don't know exactly what's being measured for each group. And so even when you throw it in the causal model, when you're predicting it, it's significant for both groups. Well, we don't know what is significant. Are you predicting usefulness, or are you predicting something else? It's
we only do it if they are
variant. Yeah. If we achieve good model fit, we're done. Don't mess with it. And good model fit in this case is a lower threshold than when it's unconstrained. So I would accept a 0.9 for CFI. That's good enough. And the RMCA can be a little higher. For metric invariance only. For configural invariance, no, it's all built into Amos. Yeah.
And then you would just, once you found that item,
you'd pin it and say, hey, here's the problem. And okay, so now what do you do then? Can you fix it without removing the item? Yes. You would then go look at that item in SPSS and split the data along the groups and say for whoever, low experience and high experience, who's an outlier? And then we go look at that outlier and see if we can remove that row instead of that variable. So we try to address an outlier on that variable. Because it's the outliers, and here outliers used kind of loosely. You're on a Likert scale, so there's not really an outlier. It's just somebody who didn't conform. Yeah. And it's the outliers that cause the invariance issues, typically.
James, if you were running this model with the common latent factor and checking for invariance in that case,
you wouldn't.
You wouldn't run
it? No, you wouldn't run invariance while the common latent factors included. Oh, that'd be terrible.
I heard somebody do that once.
Yeah. Brain blow up. Okay. So again, why do you have to do this? Or when do you have to do this? When you have a multi-group moderator in your causal model, which we do. So we had to do this.
Conceptually, what is configural invariance versus metric?
Configural invariance is the factor structure, the way we've sort of constrained things. These items go with this factor. Is it appropriate across both groups? Metric invariance is, did they respond is the wrong word, did they respond consistently similarly? Was the consistency of response similar across groups? Okay. You're welcome.
Yeah, and I apologize. Could you go over metric invariance and how you assess what your treatments are?
Treatment if you have poor invariance. If you're not.
Let's see your assessments.
Let's see. Oh, did I get rid of it? Oh, I did. That's all right. I have it. Here it is. Metric. Yes, save. Okay. And here's the output. Estimates, scalars, regression weights. Copy. And for the high experience group. Again, this was so painful before there were tools. If only. Yeah. I'm not trying to toot my own horn. I'm just saying, boy, it was hard before. That's why I made them, because I had to do this manually. Okay, so what if you end up with a whole factor that is metrically variant? Again, you would go into SPSS, look at outliers, and see if there's an issue there that you can drop a row. Yeah, it's a very, what's the word, sleuth-y kind of procedure. Any other questions? That's all I want to cover before lunch.
Does that mean that only person did not?
That person was an oddball. And now, okay, so since you're removing someone, you have to report that. And how do you report that and justify it? You say, we couldn't achieve metric invariance with this person included. We have scoped them out of our model in order to be able to move forward and test our causal model. And if a reviewer says, no, that's not good enough, then you say, well, what is good enough? You tell me. No. Yeah, that would make a difference. Yeah.
So do you assess the model for the whole model and then split the groups?
So the sequence is here, and we're going to again test model fit, final model fit after we do method bias. Yeah. I'm going to check out the Hangouts group, but you guys are free. I'm going to go again to the Cannon Center for lunch. There's a guy I'm meeting there. You guys are welcome to come with me. Or if you want, there's Subway and a bunch of other Chick-fil-A up on the if you go to the 4th floor, walk diagonally. I'm sure a student can take you. There's that. There's Pita Pit, which is awesome, and Panda Express just down the road by the CVS. Lots of good food around. There's the MOA. If you go to the Museum of Art and go upstairs, there's a great cafe up there. A little more upscale, sort of, still cafe. So, good stuff. Okay, yeah, we've answered all the questions. Okay, so we're done unless somebody has a question. I'm going to stop the broadcast. I'll catch you guys in 2 hours, 2 o'clock p.m. Mountain Daylight Time. Thanks, guys.